Hey, welcome to lesson number 1 of trigonometry. This is going to be a review of right angle trig. So looking at triangles that have a right angle and just the characteristics that make those up. So before we start, we need to remember all the different primary trig ratios that we looked at last year. And so the acronym that is usually used in order to remember this, or all three of the primary trig ratios, is SOHCAHTOA. SOHCAHTOA is sine is equal to opposite over hypotenuse. If we're looking at this example of my triangle ABO, then the opposite side is AB, and the hypotenuse is side OB. So this is AB is right here, and OB is here. So if this is my angle X, then the angle is opposite of the side AB. If we're looking at cosine, cosine is the ka in SOHCAHTOA, and that is adjacent divided by hypotenuse, and that would be adjacent side, or the angle that's beside the given, or the side that's beside the given angle is AO or OA, and hypotenuse again OB. And then finally we have tan x, which is the TOA in my acronym, SOHCAHTOA, and that is equal to opposite divided by adjacent, which is the opposite side is again AB and adjacent is OA. So first of all, with class example number 1, we want to mark on each of these triangles the hypotenuse, the opposite, and the adjacent side relative to angles x degrees and y degrees. So in this first example, the opposite side of this angle x degrees would be up here. We know that the hypotenuse is always opposite of my right angle, so this is right here, making my adjacent side, or the side right beside my given angle of x degrees, here. Next we have, and we want to complete the following given here. So remember, sine is opposite divided by adjacent, so we would have the opposite side is d to e divided by adjacent, divided by hypotenuse, which is f to e. So dE divided by FE. Cosine is ka, adjacent over hypotenuse, so that would be dF divided by FE. And then my tan is opposite over adjacent, which would be dE divided by adjacent, dF. And you do the exact same thing for this next example. So in this example, we have y as the given angle, and we want to determine what the opposite side is of y, which is over here. The side adjacent would be here, and then the side that's hypotenuse is opposite of my right angle, and that's right here. Also the longest side of your triangle. So, quick note, in solving the problems in right angle trig, we need to have a given right angle, a side length, and one other angle or side. Without those, then we can't solve these triangles. So you'll be having, for problem solving, you'll have those criteria given to you. Okay, example number 1, we want to use the Pythagorean theorem to calculate the length of ST. And so remember, Pythagorean theorem is given to us as a squared plus b squared equals c squared. In this example, we are given two sides. We're given my hypotenuse, which is c squared, and we're also given one of my lengths. And so we could call that a or b. It doesn't really matter. But in order to solve, we have to assign one of those to each of these categories. So we'll say a is equal to 7, and we'll say that c is equal to 25. And that leaves us with solving for b. Now we need to rearrange this in order to solve for b. So b squared is equal to c squared minus a squared. B squared is equal to 25 squared minus 7 squared. So b squared is equal to 100 subtract 49. so b squared is equal to 100 subtract, or sorry, not 100, 625. So 625 subtract 49. So square both sides, subtract 49, and we get b squared is equal to 576. So b, if we take the square root of 576, is equal to 24. State as rational numbers the values of the following trig ratios. So sine r. If I have sine r, then I'm looking for the, and this is 24. That's my side length there. So sine r, if this is, we're thinking about the sine ratio relative to this angle, would be opposite over hypotenuse. So that would be 24 over 25. And we leave it as a rational number. I can just leave it as a fraction. Cosine r, cosine, remember, is adjacent over hypotenuse. That would be 7 over 25. Tan is opposite over adjacent, 24 over 7. Sine s, so the sine ratio relative to my angle s would be, again, opposite, 7 over hypotenuse, which is 25. Cosine s, adjacent over hypotenuse, would be 24 over 25, and opposite over adjacent would be 7 over 24. So if we look at any of these, we have sine r. If we were to comment on the relationship here, sine r equals cosine s, and sine s equals cosine r, and then tan r and tan s are just reciprocals of one another. So calculating angles in right triangles. Remember when we were doing this last year, we had to take the inverse of the trig ratio. So if we're looking for example, x degrees here, we have the opposite side, 6, and we have the adjacent side, 5, we would have to use a tan ratio in order to determine what the angle would be. So on a calculator, we would have to type this in as such. So if we're looking for the angle, we would go 6 divided by fine of my inverse tan, and I get a measure of 50 degrees. So x equals 50 degrees. So in this next example, a telephone pole is 12 meters high and is supported by a wire 14 meters long. So let's sketch this out. So it's 12 meters high and it's supported by a wire that's 14 meters long. And this is along the ground. We want to determine to the nearest degree the angle between the wire and the ground. So angle x there. Well, what do we have here? I have my hypotenuse, and I have this side that's opposite of this angle. So if I write out my mnemonic SOHCAHTOA, then I have my opposite side, and I have a hypotenuse, which means I can use my sine. So sine of x degrees is equal to opposite over hypotenuse. Sine of x is equal to opposite over hypotenuse, so 12 over 14. And if I want to solve for x, then remember I have to inverse, I need to use the inverse sign, so sine -1, 12 over 14 equals x degrees. And x degrees, if I punch this into my calculator, so angle x is inverse sine 12 divided by 14, and to the nearest degree, 58.9 degrees is 59 degrees. Next we want to, you should go through and read this section, but what we want to do now is you use trig ratios to determine the lengths of AB and AC in the given triangle. So length of AB and AC to the nearest triangle. We want to find the correct answer to the nearest foot. And so if you go through the previous exercise, and actually maybe I'll do this. In the diagram, we were required to determine the measure of the side BC, so this measurement here. And we want to find it relative to the angle of 49 degrees. The given side is the hypotenuse, which is 17.6, and the required side is the opposite, so we use the sine ratio. And it's set up like this: sine of 49 degrees is equal to x divided by 17.6. We want to solve for x, so we need to get that by itself, so we bring 17.6 to the other side, and that equals x. To one decimal place, we would multiply it like as such: 17 times sine 49, and we get x is equal to 12.8. So, oh, and I didn't type that in right. 17.6 sine 49, that'll give me something else, is 13.3. And so BC is equal to 13.3. And part B is almost identical, right? So we cross multiply to isolate one of the variables that we're trying to solve. And we're going to do that here as well. What we're looking for here is we want to use trig ratios to determine the lengths of AB and AC in the given angle. So AB, we call that x, and AC, we call that y. So these are what we're trying to solve. Now we're looking for the hypotenuse, and relative to this, we're looking for the opposite side. So the first thing we want to do, since we have adjacent already, well, we could choose to do either one, but let's find out x first. So in order to find x, we have the adjacent side and we have the opposite side. So that's the tan we're looking for. So we know that tan of 74 degrees is equal to opposite over adjacent, or x over 109. I cross multiply, bringing 109 up, times tan 74 degrees, and this equals x. So 109 times tan 74 equals 380 to the nearest foot. X equals 380 feet. Now, in order to solve y, I have hypotenuse. I still have 380 feet, but let's use 109 just because that was the given length. But I could use my cosine because I have my adjacent and I'm looking for my hypotenuse. So cosine 74 degrees is equal to adjacent over my hypotenuse of y. Cross multiply, bring y up here, switch places with cosine 74 degrees. Y is equal to 109 divided by cosine 74. And I get 395 feet. All right, the next example, a large tree is to be transported to a new location. The tree is held vertical by means of two guy wires of unequal length on the opposite sides of the tree. One of the wires makes an angle of 48 degrees with the ground. The other wire is 12 meters long and makes an angle of 56 degrees with the ground. Both wires are attached 3 meters down from the top of the tree. All right, so 3 meters down, that's where they're both attached. We have one that makes an angle of 56 degrees. And for this example, protractor is nice. So 56 degrees. So let's say that's 56 degrees here. And another one that makes an angle of 48 degrees. So like that. So the tree is held vertical by these two guy wires on equal length. One of the wires makes an angle of 48 with the ground. The other is 12 meters long and makes an angle of 56 with the ground. Okay, so this is the one that's 12 meters long. And we're not told what this angle here is, but there are some things that we can infer with this scenario. And one of those things is this. So we could draw a vertical line down, say that's 180 degrees, and there we have our right triangle. In which case we have our lengths A and B right there. We want to determine the height of the tree to 1 decimal place. The reason we drew this is because we know what this length is. This is 3 meters down, right? That's the information we're given. And we don't have this length. If we solve for this length of x, we can determine what's the total height of the tree if we add it to this 3 meters. And so we can use, this is an opposite side of either 48 or 56, but let's use one of the ones that we have a length for, which is 56. So sine 56 degrees is equal to x over 12 meters. I cross multiply this. This becomes 12 times sine 56 degrees is equal to x. And x, so 12 times sine 56 is 9.9. So x equals 9.9. We're looking for the tree height, and so the height of the tree is equal to x plus 3, or 9.9 plus 3, which is 12.9 meters tall. Next thing we want to do is determine the length of the other wire to the nearest tenth of a meter. So we're looking for this now. I'm gonna store this in my calculator because that's what I used here was a rounded 12.9 meters, and my length of x was actually more than that. So I'm going to use the stored measurements there. Another thing I could do is so you could use the rounded answer, but you're going to lose some of the value that you have for here. But let's look at sine 48s, and we know that sine 48 degrees is equal to x over y, opposite over hypotenuse. Now we're using our stored answer, so sine 48 degrees is equal to x over y, but remember x is also equal to 12 times sine 56. But what I'm going to use is I'm going to use my stored answer, but I'm just going to input 12.9 in my equation equals y. And if I rearrange this, y is equal to 12.9 divided by sine 48 degrees. And I stored that as alpha A in my calculator. Alpha A was 9.94. And so I'm not using, and I shouldn't use 12.9 here. I should use 9.9. So 9.9, that was the value of x. You could also input 12 sine 56 divided by sine 48, and you'll get the same value. But this is a little quicker. So divided by sine 48, and I get a value of 13.4. So y equals 13.4 meters. So that's the other guy wire. So that's 13.4 meters here. All right, now we want to determine to the nearest tenth of a meter the horizontal distance at ground level. So we're looking for A and B. And so that I'm going to leave with you, and we'll look at this at the beginning of class after Thanksgiving.